Hello, welcome to the course of IPv6. So today we are going to discuss about the DNS server. So in this class we will discuss about what is DNS, then the term associated with the DNS server, and then the working of the DNS, and then happy eyeballing and DNS security extension. So let's first start with very first start is what is DNS. So here the DNS is a name resolution protocol and it is known as domain name system server. So it is a powerful, extensible and flexible system that is used for resolving name over an entire internet. It means it is used to resolve the name of the URL to a particular IP address or the resolution of the IP address to a particular URL. So here the DNS use TCP port 53 and UDP port 53 for the resolution. This technology make easier for the people to remember the words rather than the number, as it is very difficult to remember the IP address for each website. So these DNS servers make it easier for the people to remember only the URL of a particular website. For example, as we want to open a web page for a Google, we will type www.google.com instead of typing its IP address as http://2001:4860:4860:8844. So this is the IPv6 address associated with the Google website. So as we want to open this website, we only type the URL. We will not type the IP address of this, as IP address are not easy to remember for the people. So here the need of DNS is more in the IPv6 because it is very difficult to remember such a long address for a different website. So let's start with first that what is a DNS server. So DNS server is a collection of computers that want to join domain name system. So they work as a team and collectively known as DNS root server. So the internet name of this computer team is dot. We will use the dot to represent the DNS server in the internet system. So the DNS servers are organized in a hierarchical form which include the top level domain names such as .com. For the organization we will use org, for the network we will use the net, and for the educational institute we will use the edu, and for the government website we will use the gov, etc. The DNS root servers are the top level domain servers and it include a complete database of internet domain names and their corresponding IP addresses. So the low level DNS servers are owned by the businesses and the ISP, that is the Internet Service Protocol. So this is the hierarchy form and the DNS server system. After that, the next part is the terms that are associated with the DNS. So the very first term is the domain namespace. So the naming system on which DNS is based is a hierarchical and imaginary tree structure called the domain namespace. So it includes all the possible names that could be used within a single system, and each node in the DNS tree represents a DNS name. So this is the form of a naming system in DNS, that is domain name space. So here a diagram shows that there is a first of all there is a root that is represented as a dot. After that, top level domain names are like .com, education, org and the others. And the second level domain names are the name of the website like Telcoma Trainings, that is the name of the website, Stanford and physics. So these are the particular names that represent the second level domain name. After that, the subdomain name is the www, that is World Wide Web. So whenever we type a particular URL like www.telcomatraining.com, then it represents a complete address of a particular website, and whenever we type this, the DNS server resolves this particular URL to its IP address. So there are the top level domain names, second level domain names and the subdomain names in a domain namespace hierarchy. Then is the name server. So here the name servers include the DNS name server, Jones and Record. So first of all, what is a DNS name server? So it is a computer that has DNS software installed on it, and it is specially designed for managing the different domain names. After that, the John is a zone is a container which holds the records of a single domain. Here a simple network has a DNS server for the entire network, and a single domain name can use more than one DNS server. For example, like a google.com is a busy domain, so it needs multiple DNS server to support all the incoming DNS queries from the user. For that, we have to represent a multiple DNS server for a particular domain name. So the next part is record. Record is a line in data that contained by the zone which maps an FQDN, that is fully qualified domain name, to an IP address. Means whenever we write the www.telcomatraining.com, it will represent a complete URL, that is FQDN, and then it is resolved to a particular IP address in a network. So this is the meaning of DNS: name server, zone, and the record. After that, the next part is the IPv6 define the two type of record types. The first one is quad A, that is represented as quad A type record, and it is represented and defined in the RFC 3596. And the second record type is A6 type record, and it is defined in RFC 2874. So the A6 type record is designed to make renumbering of network and prefix changes easier for the network administrator. And the other DNS records are also there, like NS records and PTR records. They remain unchanged as they are also present in the IPv4. So only these two are supporting the changes for IPv6 network, that is quad A and A6 type record. Next is the name resolution. So the name resolution means successfully mapping a DNS domain or host name to an IP address. So there are many ways to resolve the name in DNS, like by broadcasting. So the particular host that want to know its IP address or the host name, then it can broadcast its particular host name to know the IP address, and if it knows the IP address, then it can broadcast the host name in a, but this part is only take place in a small network. The next part is the by locally consulting the locally stored host text file. It means we can consult a locally stored at a database that can contain the text file that contain the information about the IP address and the host name of all the computers that are present in the network. After that, by contacting a DNS server. So last, this is a main role. This play a main role in DNS, that we can contact a DNS servers to resolve the name of the host name to a IP address. Next part is the how DNS server work, or the working of DNS server. So here the DNS act as a central part of internet, and it provide a way to match website names or the computer names to their IP addresses. So first of all, a user type the name of website in search engine, and which generate a query and is sent over the internet. So this is the first part. Whenever a user type a name of the website, it will generate a query. So let's suppose the user query first go to the recursive server that is operated by an ISP, and it is present in this client link or a user network. So the recursive resolver know where to send the query in the network. After that, then recursive resolver talk with the root DNS server about the IP address of the website. So it will talk to this root DNS server about the IP address of the network, and then root DNS server search for its particular top level domain TLD by analyzing the domain name of the website. So it will analyze the domain name and find out the particular top level server. So when it finds the top level server, the query is sent to the particular TLD server, where TLD server stores the address information for the second level domain within the TLD. So the second domain level is the name of the particular website. So this is the top level. It will decide for the top level, and then it is decide for the second level domain. So whenever it gets the information about the second level domain, then the TLD server gives the IP address of a particular DNS which knows about the IP address of a website to a recursive resolver. So here the IP, it knows the IP address of a particular DNS server that knows the complete information about the URL that we have typed in, that the user typed in the computer. So it will send the IP address of particular DNS, and then root DNS server will again send the IP address of the particular DNS server to the ISP, that is the recursive resolver. So after that, as the recursive resolvers know the IP address, then recursive resolvers send the query to the DNS, as DNS knows about the IP address of full domain and it tells the IP address of the website. So as now ISP know about the IP address of a website, or know the IP address of a DNS server that contain the information about the particular URL, then it will send the query to that DNS server, and then it will extract the website IP address from that DNS server. So here the recursive resolver send IP address of a website to the user, and thus the website appears. Now user can browse the website and retrieve the content using the IP address. So this is the working of a DNS server in a network. After that, the next part is DNS dual stack query. So in the case of dual stack network, whenever a host query a DNS server for service name by entering a URL in a browser. So a dual stack network is a network where we have the IPv4 as well as IPv6 addresses present. So the client sends the two DNS requests, A record and query A record. So the DNS can use either of them or both to answer the query according to the DNS configuration. And when client receives two addresses, then address is chosen according to the default selection rule. So this is depend upon the DNS server and the client to choose which of the address by in a dual stack network. Next is DNS Happy Eyeball. So this is a method which is used to improve the client experience in a dual stack network, and it is defined in RFC 6555, and its operation is like when a client gets two addresses for a given service such as IPv4 and IPv6 address. By default, it will connect to the IPv6 address by initiating a TCP handshake. First of all, it will choose the IPv6 address to connect. If no reply is occurred of the request, the client wait for long time, and when time outs, then the client use IPv4 address. So the reply node comes due to the slow and broken IPv6 path. Then with the implementation of Happy Eyeball technology, the client can try both the protocols and then can use the faster one for the communication. The next part is DNS security extensions. The DNS security extension, that is DNS SEC, is an authentication and authorization protocol to provide security to DNS server. So DNS SEC is a suite of Internet Engineering Task Force specification, and here the securities are added to protect DNS from unauthorized user. So DNS SEC is implemented through extension mechanism for DNS, that is eDNS. So this is all about the DNS server in detail, and thank you.